It's time for another exciting episode of hello to our chat. We have chat people over in our YouTube. Jeff Gortatowski from West Virginia. Hello, Jeff. Thanks for joining today. And Dave Odessa. Hello. Hi. We have also got our Discord chat. That's the main chat we use. So if you're wondering where the chat is over on Facebook or Twitch or one of those places, you could check out our Discord. And oh, the audio is being dodgy. Don't be dodgy. Why? Why? All right, audio. Why are you dodgy? Is it clipping? No. Is it low? Hey, you tell me. Better now. Do we have a loose cable? Let's double check. Oh, that's got pinched. Yeah, that's probably not great. Tell me if we get, what's the dodgy? Was it going in and out? Was it static? I'd love to know. Good to try to catch these things in advance. And yeah, the people saying these things to me are over in our Discord chat. So if you're wondering where that is, go to adafru.it. That's our URL shortener. adafru.it/Discord. And you can look for the live broadcast chat channel. Sounds like a noisy connection. Well, let's see. I'm going to turn this sound down for a second and rejigger this connection. Hold on. All right, turning that back up. Let me know. I'm not sure what my level was on. I was unfortunately fooling with microphone stuff because I wanted to be able to mic an amp today. So I'm going to watch the chat for another second. There's a bit of a delay between when I say things and when they get broadcast and the chat can respond. So sorry for the pause here while we work things out. Let me know, and then we will proceed with the show. Lars chewed through the cable again. Lars, why? And now it's kind of worse. Still flaky. Oh no! I wonder if it's just this connection to the pack. Can I shore this up with gaff tape? Is the question. I don't think it's flaky here. Hopefully not. I'm also going to turn that up. The gain looks a little low. So, whee! Isn't this fun? I'd love to have a backup mic, but I do not. I don't have a backup plan for my mic. Yeah, that does look suspiciously low. It got better after a bit. Could it have just been low? Huh. I'm going to grab some gaff tape. Pardon me while I fix this. I guess I could grab a handheld mic and just talk to you that way. Let's see. I'm just going to wrap this around the end of the cable here. Oh, I hear messages coming through. Bring my tape with me. And it seems fine now. Hey, I hope that stays that way. All right. Much better volume. Yeah, I messed with things. I shouldn't have messed with things. Okay, thanks, King or North. Thanks, Todd and Andy Calloway, everyone in the chat for helping. And cross fingers it stays that way. Douse it in hot glue and gaffer tape, and you'll be okay. All right, good. Well, let's get on with things then. So, first of all, what do we have going on today? I have a coupon code to give you so that you can go and buy some things in the Adafruit shop if you like and get a nice 10% off. I have a product pick of the week recap. Part of the theme going on here is hardware problems. I was having some hardware problems this morning setting up part of today's project, and so I ran out of time to do a CircuitPython Parsec. So we do not have one, I'm sorry to say, today, but next time we will. But so there won't be a CircuitPython Parsec. There will be a product pick of the week. There will be a little learn guide recap, a quickie learn guide recap. And then we are revisiting a project, sort of, that I was working on a few weeks ago, and that is the USB MIDI host, or USB host Feather, to host a USB-only MIDI keyboard and then send that out over UART, over classic MIDI, to old synthesizer. In fact, you can see it right there, that one on top. That's an ancient, I think it was a 1983 or so synthesizer that I got at a estate sale a little while ago. You might remember that one. That was the one with the repair notes on the inside. So that thing, I can't use that. That only has classic MIDI, and I have this little, Akai MIDI controller at the bottom there is USB only. So we're gonna use a little gizmo in between. Spoiler alert, the problems that we were having still exist, or I was having, which is the speed of some of the messaging in CircuitPython. But there is there's an Arduino library that does the job, and so I'm starting to dive into that. I got it working pretty well, and I'm also going to add some features that we'll talk about. So that's my my little project revisit, and we'll see where we get that, and then maybe if I can do a learn guide on that, and eventually we'll get a CircuitPython version up there as well, because I know people love the CircuitPython for how easy it is to deal with. And that's going to be it. That's the show today. So first of all, the much promised coupon code. So if you want to go to the Adafruit shop, this place, no, not that place. We'll get back to that. This place right here, adafruit.com. You can see we have a nice little set of new products called out there at the top. We can click on the View All New Products, check these out. Some neat stuff, and you could get some of these things for 10% off of your whole order by just using that coupon code right there, Phaser. Phaser will get you 10% off today. You just type that into the coupon code slot at the bottom of your shopping cart checkout area on checkout. And that won't work on gift certificates or software or subscriptions, but it will work on any of the physical goods that we sell in the store. I don't know about like clearance items. Do you know we have a clearance section? That's kind of fun to look at sometimes. If you head over to products and you see this categories, clearance sale is the last one there. I think maybe the discount works on these. So if you if you are interested in any of these things, I think you can also get the extra 10% off on those. Don't quote me on that because maybe I'm wrong, but I think that I'm right. I think you can. When you get your stuff, just remember to use that coupon code right there. The reason for that coupon code is that synthesizer that I'm using right there, the Casio, that used a type of synthesis called phase distortion that I believe Casio invented, or they got, or they licensed from someone. But it was an attempt to create synths similar to Yamaha's DX7 and others that used FM synthesis, since Yamaha had that sort of on lock. Anyway, phaser. That is the coupon code of the day, and that's thanks to that phase distortion. In the chat, Mike P said, follow up from last week's Parsec. You can create the help message for your class function method by adding a comment immediately after the def line. Thought I'd throw that out there. Oh, that's pretty cool. I'm going to try that sometime. Maybe I can show that next week. Thank you, Mike P. I'm copying and pasting that right now into my notes so that I remember for next week. That's great. Yeah, where do these help notes come from? Now we'll get to explore that. Thank you. Also a note from Todd: a quick CircuitPython tip I've been wanting to use is a new way, well, new to me, to tell what kind of board you are on. Oh, let me show it since he's typed it up. And that is import OS uname, ugh, so much, import board.board ID, and it tells you, it's much cleaner, yeah. How nice, how nice. Thanks for showing that too. All right, I'll bundle up some of those tips together maybe for next week. Thank you, Mike P. and Todd. All right, so let's take a look at this product pick of the week. So I've got my product pick show on Tuesdays, and I like to make a little condensed 1-minute version of it that you can check out now. So here we go. My product pick of the week this week, it is the Gemma M0, everyone's favorite little round microcontroller board, everyone's. You can run Arduino on it, you can run CircuitPython on it, and you can use MakeCode simulation of the board with the code that it's running. So you can see right now I have essentially capacitive touch running. If I hit D0, my dot star goes red. If I hit D1, dot star goes green. If I hit D2, dot star goes blue. And I have essentially duplicated this one block, which is found here, input, on touch D0 click. So I drag that out there. And then I modified it in this case to say on down. So when I touch it, or on up, when I release it, it does different things. It goes red. And I have on release, they all go to yellow. So there we go to green and back to yellow, and blue and back to yellow. Is my product pick of the week this week. It is the Gemma M0. Yes, indeed it was. So let's, sorry, we're skipping the CircuitPython Parsec, like I said. We don't have one for today. I debated during the 1 minute that we just watched that video, trying to throw together Mike P's example real quick, but I figured that might be a bit of a disaster. So we'll hold on for a week and do that next time. So next thing I want to do, however, is take a look at the updated Learn Guide here for the TRRS Trinky, as well as the Xbox Adaptive Controller. So I'm going to click on All New Guides, and here we've got this Adafruit TRRS Trinky Guide, main guide, by Liz. And I've added this page right here in CircuitPython Essentials. I have the adaptive joysticks. So this Trinky, you can use it for a lot of things, but one of the primary uses for it was to enable various adaptive controller options on computers and game systems. And one of the really neat things it can do is it can emulate an Xbox capable joystick, USB joystick. So that adaptive controller has a lot of plugs in the back for adding different kinds of buttons and switches and things. But on the sides, we have 2 USB ports where you're meant to buy something like a flight stick, plug it in, and then that will take the place of the thumbstick, which gives you a larger controller to work with. So the cool thing is that our little TRRS Trinky here can act like that kind of a joystick, that kind of a gamepad that the Xbox Adaptive Controller is expecting. And I did a couple of versions of this. I did the analog 2-axis thumbstick, which is actually honestly pretty similar to a gamepad thumbstick, so it may not be what you want to use, but since it's a broken out item with its own mounting holes, it's more convenient than a thumbstick that's on a controller. So you could potentially use this, and the thumbstick cap is easily removable, so you can add things to it, drill a hole, add a stick to it, 3D print things. So that's a pretty nice option. It's only $6. You could also use our little mini analog joystick, which is a pair of 10K pots as well. I had some swirly aluminum mounting grid on there just for my example that you can see there. And in my example here, you can see there's the wiring diagram, both for the fritzing connection to that joystick, as well as a guide to what the TRRS 3.5 millimeter plug is being assigned for each of its 4 conductors. You could kind of do this any way you want. Since we're plugging it into that TRRS Trinky, we can have any pin be anything. The ground is just a output pin being set low. Same with voltage. So that could be anything you want. The reason I ultimately went with this is it mimics a layout used in other places on the Xbox adaptive controller. So if you wanted to plug this in elsewhere, the same wiring setup would work for you. And then I have a little wiring on the bottom there, some Kapton tape. You can see there's a position there you don't use. That is the click switch. So this thumbstick has a click switch in it. You could certainly wire that up and then run that to another of the inputs on the Xbox Adaptive Controller. The joystick connections are not looking for a button, I don't believe. So we're just using the XY axes. And there's a little pull-out view of the cabling. And then we just plug that into the adaptive controller there, and then that just will show up under this code with the proper libraries, and all that's in the project bundle. If you're not familiar with this, by the way, in the Adafruit Learn Guides, when you see a code example that says download the project bundle, hit that, because you're going to get not only the codes, you don't have to just copy paste it, but you're going to get any libraries for basically the most recent 2 versions of CircuitPython. So you'll get the 9.x and the 8.x versions, and then any other assets or supporting materials that you need. They'll all be in that zip file. Just drag those where they're needed into the CircuitPy drive or the library folder. That's the code there. And then I have a little example. It's actually just from the live stream from a couple weeks ago, showing that in action in use on the adaptive controller connected to my laptop. So it'll work with Windows laptops, and that'll work on Xbox systems. I think both the Xbox One, Xbox Series X. I'm not sure about older ones. I don't think that'll talk to the Xbox 360, but I should try it. I do have my 360 still. So that is the added page to that. And thanks, Bill Binko just showed up over in our chat, AT Makers Bill. Thanks, Bill, for helping put together a bunch of the code that's used in this. And he's also got a project that is used to simulate joystick movement using chording combinations of 2 buttons. So that code, I believe, is also in the Learn repo, and I think Bill's just working to finish up that page. Yeah, Bill confirms everything Xbox One and newer. So that is the updated Learn guide there. And then if you go into the Learn system and look up XAC, Xbox Adaptive Controller, this was the previous guide with creating different types of buttons and some analog things to simulate, like the trigger buttons. Those are used for like gas and brakes in racing games a lot of the time. That goes into more detail about the layout, the standards. Here's that cool view of all of those inputs that are on the back there. And I don't know if I have a picture here of the side inputs. I think I do, actually. Yeah, there's some of the wiring diagrams, analog input standard. This shows you how to set up more typical buttons and switches, and foot pedals, latching switches, and then in the analog input section I had some connected directly. Like I said before, you don't actually need the Xbox, or rather the TRRS USB port plugged into the side to do thumbstick stuff. You can use one of the analog inputs that's on the back with basically the same wiring. However, you may want to use the joystick code to filter. So normally this would just be like a dumb set of potentiometers plugged in. If you want to do any kind of filtering, like latch motions, add ease and in and ease out, other code-based things, then you'd want to use the TRRS Trinky, but it's not a requirement. So here it is being used just on one of the analog inputs. And then I mentioned the USB inputs in the original article. Now I've just merged this page in over here. So we have a way to take pages from one guide and just mirror them into another. So if we make changes in one, they'll appear in both. And I believe there's a page in the TRS guide about using that Trinky as a mouse. Where is it? So I think this one, CircuitPython AT switch example. No, where is it? Maybe that's a... I thought Liz had some sample code here. Maybe it's in Arduino, or I'm just missing it. But yeah, I think there's some code there about using the TRS Trinky as a mouse as well. Code's there, page is not. Okay. Yeah, so if you go to the Learn repo, there's probably a faster way to get here, but if I go to Adafruit in GitHub and look for Adafruit Learning System Guides, if you search TRS Trinky demos here, so we have the AT demo, analog mouse, there it is, chording joystick, 2-switch keyboard, TRS Trinky AT demo, and the new USB joystick one that I added there. So go dig in, see what you find out. All right, so let's dive into this USB host revisiting thing a little bit. So I'm gonna, first of all, this is the board I'm using. So we have two ways of doing USB host. Do I have the other one here? I don't think I do. So we have a Max 3421E chip, which is a venerable USB host chip. We have that built onto a Featherwing, and we have it on a BFF for QT Py. I'm not using that one. I think it could be used, but I found this, actually ToddBot showed me this library just yesterday that's available in Arduino for use with the RP2040. And the way this does it is by using one of the PIOs, one of the little state machine chips, to bit bang the USB host stuff. So it's over there being a USB host. Actually, I'm not sure if it's bit banging it, but it's being the USB host while the other core is available for the rest of the duties like MIDI stuff, so in the case that I'm using. But this is essentially a Feather RP2040 with the usual bells and whistles, plus you can see it has a Type A port there, so you plug in sort of your typical this end of your stuff, usually in the USB spec before you get USB-C, where they look the same on both sides, but usually you'd have things where the hosting side of the equation has this port. It wants this plugged into it. And that's the case with these MIDI keyboards. So I'm going to unplug this. So here's a typical modern MIDI keyboard. Very inexpensive ones have kind of one plug in them, and that's about it, and it's a USB port. This one happens to use an old big honkin' USB-B, kind you usually see on printers and things, or used to at least. So this end then needs to go into usually your computer, or a very expensive modern synth that can do hosting capabilities, or if you have a Raspberry Pi that's acting as a synth or as a host box. So this has been the frustration, is a lot of these inexpensive MIDI controllers you can get, and they can be sequencers, they can be arpeggiators like that one, they can have dials and knobs and pads on them to do extra special things, but they typically expect you're just plugging them into your laptop and using software synthesizers. But we really want to be able to use them on everything, so that's why this USB host on a Feather is so exciting, because we can plug the synth into there, and then with the right code, we can use that, we can read that, we can deal with those incoming messages, and then it being a programmable microcontroller, again, you can pass those back along over USB. In this case, I'm going to pass them along over a MIDI Feather wing, which is sending out classic MIDI, classic DIN5 or TRS UART MIDI, serial MIDI. And we can do things like add an interface to it, do some filtering. Let's say you want to lock things into a certain scale only, or you want to be able to, on the fly, change what your MIDI CC knobs are doing. All of those things are reasons why you'd want to put a little microcontroller in the middle, which up until now has tended to be pretty hard to do. There were some teensies that could do it, but otherwise, most of the projects that attempted to do this put a full Raspberry Pi single board computer running Linux in the middle to host some MIDI and then send stuff out. So the issues that I ran into before, last time I tried this about a month ago, were in CircuitPython, and there are some underlying issues maybe in Tiny USB and elsewhere that are causing it to drop notes. And with MIDI, you usually send a message to say, start playing a note, both the pitch and the gate, or the fact that it's on. And then another message when you say, okay, stop playing that note. When you start missing messages, you get held notes. That's the first sign of it, is that you get a note that's just playing forever, even though you're no longer touching the keyboard. You just have to reboot the synth usually, or send a MIDI panic message. So that's a problem, and what Todd Bott found was this, let me see if I can pull it up here, this library for Arduino that can use the RP2040 Feather host and read incoming MIDI, host the MIDI keyboard, and then send out messages over whatever interface you want. Todd had taken some sample code and had it mirroring or echoing those messages over let's see, there's some sample code from Todd. Let me find the library itself. Over USB, I was able to very easily add to that so that it also sends out over UART. And let me find, is this it? Yeah. Oh, no, that's Todd's example also. What am I looking at here? Here it is. So it's called Easy USB MIDI Host, and it sure is. So this is by RP Pico MIDI is the user. And I'll just post that library right there over to the chat if anyone wants to go check it out. And this has some examples, I think, for maybe a Pico and the Feather in Arduino here. There's an example, and there's a PIO example. Okay, I don't know what the difference is with those actually. So here you can see this was, I believe, the example post that Todd had thrown my way that I was able to get running pretty quickly and easily, and then I just added a couple things to it. So let me bring up this in Arduino, and you can see here we are essentially just adding the one library, this Easy MIDI host library, And then I've also added in an OLED, and actually I'm going to bring it over here before we do any real demos. I'll just show it to you in person. So you won't hear anything, but maybe we'll print some prints to it. So right there, it's just sitting on a feather quadrupler there, so that I have room for a MIDI out feather wing, as well as I for now just have a little baby OLED on there running over STEMMA QT. I had a burned out piece of hardware. Remember I told you I ran into trouble this morning? It's because I had an OLED feather wing that turned out to be faulty. And I spent way too much time trying to get it to work. So let me focus in there. So I'm going to go full screen on that actually for a moment, so I can actually focus it. That's about it. So you can see I've plugged in my MIDI keyboard using this blue cable here. And as I'm pressing notes on here, you're just going to see their message come through. So it's saying it's on channel 1. There's a note on. It's note number 57, and the velocity is 50. If I press harder, when I press it down, you'll see here's a different note, and that's at a velocity of 123, about almost the top. When I let go, it says that that note number is off. And sorry, there's a little smudge on the lens, maybe, or I need to adjust the... yeah, let me adjust the exposure a little bit so you can read that OLED a little better. Yeah, it was kind of blooming out there. So you can see those better. So that's me pressing keys here. And I'm not doing much interesting with the display right now. It actually is a little slow to write to. I had been showing when I dialed in MIDI CC values before, but those were slowing things down so much that it was a problem. So the display, I'm going to use that, I think, for UI stuff, like I said, where I can filter things and I say, oh, let's change the outgoing MIDI channel, right? It's coming in on whatever this MIDI keyboard is set to, and on this particular one, I can never remember how you change the output channel on it. There's no obvious markings on it for how to do it. So rather than go pull up the manual online and do it, I can just send out on whatever it's sending out on, in this case channel 1, but then we could set this to write out to any channel we want, 1 through 16. So those are some of the sorts of things we can do there. But right now, if I, let me see if I can show, I'm going to plug this in. Right now it's just running off of a battery. I'm going to plug this into my computer here over USB. And let me see if I can add the MIDI monitor program here so you can see that. 1 second. New screen capture. Window. MIDI monitor. Untitled, yes, okay. That's good. So this is a helpful app, and there's a lot of free, similar free apps for different operating systems that show you what's happening over in USB MIDI land. So the program that's running on here is reading in the MIDI messages from this host port, and then it's echoing or resending those right now unadulterated, those same messages both out over the UART, which is just the TX pin, and I'll plug in the MIDI wing in a second and you'll see that working. And now it's also going to send out over the other USB port, the kind of original USB port, which is what we see right here happening. So as I'm playing notes, they are being sent out from this little keyboard here. Those go through, host figures them out, and then resends them over 2 different transports, both USB MIDI and the UART MIDI. So if we want to, we can do these little knobs You can see here, it's not just notes. I'm not, like I said, displaying those on the OLED, but you can see here as I change this controller, that's over control 1, over 82, over 4. So these are the different MIDI numbers, and those can mean different things to different synthesizers. Some of them are sort of known defaults, some of them really can vary a lot. And again, it'd be nice to be able to say, oh, this is coming in on 27, I'm going to send it out on 56, which I'm using to adjust the filter cutoff frequency or whatever it is that you have on the other side of it. So let's take a look then at the practical example over here. So let me switch back over to this view. So I'm going to unplug that from my computer. I can keep all this together here. Let me throw a little main view there. And I'm going to turn up the microphone input volume because I have a little amplifier there so that hopefully through that real mic, it's actually a guitar amp mic, you'll hear this better than you will just picking it up over my little lavalier on my shirt here. So let's see, we've got, just leave the big battery there. One reason to use the battery, by the way, is to avoid ground loop hum. I've got a lot of things that are plugged into power, AC power circuit. Having some of them on battery tends to help with avoiding ground loops. I don't know if we would have one in this case, but rather than fight it, I'm just running this off of a battery. It could be run also off of the USB battery pack, but there's no need for the main USB port on here to be connected. It's just the input host that I'm using. And so this right here is a a MIDI DIN5 Featherwing. It has the little opto isolator chip on there. It's a proper circuit for optically isolating your devices, which is part of the MIDI specification for classic MIDI stuff. And this is just basically ground RX TX are its only connections to the Feather. And so now that's sending out over that big DIN5 MIDI cable to this old CZ01 Casio phase distortion synthesizer. Let me see if it's just have it running through a little reverb effect. Turn that on. Okay, so this is the tell me if you can hear that and if you can still hear me. And I'm going to bring up my Discord chat so I can see if that's working. And oh, I don't need a new app icon. Thanks, Discord. Yes, live broadcast chat. All right, so I'll keep that open there. You let me know. And what I'll tell you about this synth, it actually is old enough that it does not have a ton of MIDI CCs implemented. In fact, it's just the portamento, which is sort of a glide between notes, and a vibrato. Those are kind of the on-off are two MIDI CCs used as sort of a switch. And then there's two other MIDI CCs that are used as continuous controller changes to adjust the timing of those. However, one of the neat things is that the program change, which is essentially which preset am I using. So you have usually on these things, this one has, I think, 16 built-in presets, and then I have an additional, I think, 64 or 32 on a card there. So you can design your own sounds with the myriad settings this has, save them, download patches from other places. But to be able to call them up, we can actually send those program change messages also over our little gizmo here, which is neat because you can even, again, because we have a microcontroller in the middle, we can get fancy and we can have things like changing program based on other MIDI events. I think you could probably split your keyboard and have it send some stuff from one hand, not at the same time, but when you go to some other notes, it could automatically switch program. There's some interesting stuff you could do there. And this has a terrible keyboard on it. This is a squeaky little bad keyboard. This is not that much better, but it is better. So being able to get like a nice big weighted bed keyboard, that's another reason you would do this sort of thing, and just treat this like almost like a desktop synth. You could hide it away. And then of course all of these modern things like an arpeggiator. So that's what I'll demo here. So first of all, so that synth right there. That right there is coming from MIDI. This RP2040, I'm trying to answer a question in the chat here. The RP2040 is hosting the Akai, and then it is sending out all of its MIDI messages to the Casio, if that makes sense. Ignore this thing up here. So that's the path right now, is that I'm hosting. If this weren't here, there would be no way to use these two things together. This only reads in this kind of classic MIDI. This only sends out USB. They were made 30 or 40 years apart, so there's actually no way to talk to these two without something like this in the middle, without a USB MIDI host. That's the special job this Feather RP2040 is doing there. So first of all, I'll show you program change. I can just hit program change on this keyboard, and then these 8 pads. If you look at the name here at the top, you might be able to see it's not a lit keyboard. It says electric piano, brass ensemble, trumpet. Let's do something fun. I'll turn on portamento. You can hear it scoop up, scoop down from whatever the last notes I played. If you see me doing it here first. If I adjust, I think it's this one, you'll see that portamento time go up. It takes it like 20 seconds to glide. That's its maximum time there. That's too long. Put that a little more moderate. Again, these things can it's a digital device. It can do just about anything. We can set the octave up higher. That's so annoying. I'm going to turn down that. Actually, I'm just going to turn off that portamento. And I think that on-off switch can be mapped here as well to CC. So another thing we can do, I'm going to scoot out a little bit here, is, let's go to another. All right, we'll go to the synth bass. I'll drop an octave. And now I can use this thing's got a little arpeggiator built into it. We could also write an arpeggiator on here if we wanted to, but if we, there's no capability on this keyboard to do arpeggiation. So what I'm going to do is turn on the little arpeggiator here, set it to latch, random, eighth notes, and how about 2 octaves? We can even continue to tweak parameters on here, like what synth sound are we using. So all this is doing is transmitting a little MIDI message over USB to my Feather, and it's just passing that message along over RX, essentially serial UART, to the Casio, to the CZ101. It might just be semantics, but again, Bill was saying, so the CZ101 is a MIDI host. It's not really, because the notion of host didn't really exist in UART MIDI. It was serial, 2-way, it has an in, it has an out. I don't think host was a word really used with that kind of MIDI, so it's more that I need a host, which is the Feather, and then it's hosting the Akai, and it's passing along those messages to the Casio. Oh, percussion, that's no good. Yeah, kind of a Close Encounters vibe. So that's the pitch bend here, which is another message that's being picked up here and sent along. Modulation I don't think is hooked up. So usually that up and down I think is the same as this one, which would change the modulation, which is kind of up to the synth's patch, what that's going to do. But yeah, so I have 16 different patches on here actually. So this was patch 1 on bank A through to 8, and then I can go to bank B. So that's pretty typical. We got 8 knobs on here that could be set to, I think there's maybe 3 things is the master tuning, which I wouldn't want to actually hook up on this, but most synths would have way more than 8 parameters. More modern synths would have more than 8 parameters they can use. So that is the main thrust of that. And then just to show the versatility here, what I'm going to do, let's turn off this synth. I'm going to unplug that MIDI cable. Let me zoom out so you can see some of these machinations a little bit better. So I'm going to unplug that MIDI cable. I've got a janky wire there. And I'm going to just set this synth off to the side. And then here's another one that uses the same type of DIN5 MIDI connector, although this is a much more modern synth. This is a recreation of an old synth, roughly the same era, but this is a digital recreation of it that was made, I think, in the last, 6 years or so. But it does not have USB MIDI host, so it does not, I don't think we can plug in a MIDI keyboard into there because it's not a USB A, that's a USB B. This thing is meant to plug into something that hosts it. So we could host this on a computer, but we've again got just our friend the DIN5 MIDI. Plug that into the in. Let's grab an audio. So this is a line out audio coming from here, and we'll bring that into the little reverb. This thing's level is a little low, and I can't remember. Is that the volume? Yeah. So again, this has a bunch of patches on it. Oh, my main camera just went out. Let me turn that off. Is this good camera turning off music? It may be time for a new camera. So this has patches on it that I can switch around with here, but I should be able to also change them right from this. So again, this can kind of be out of the way. I have not tested which CC knobs. These are all parameters that can be adjusted with knobs on here. Kind of don't need them because they all live right there, but see if any of them are. That's doing something, although I don't hear it. Nope. Doesn't even do it on board. Yeah, thank you, Andy. My camera definitely died over there. I turned it off, but I didn't remove its dead signal there. Let me go do that. Actually, let's see if it's ready to turn back on. It's trying. Here we go. All right, so that's a couple of examples there, and then I also have one of our other, you can do the MIDI featherwing with just the little simple TRS outputs on there. So if I get this out of here, the little box I've been using as a reverb is also a little tiny synth that, yes, you guessed it, cannot host a USB keyboard. So there's no way to plug these two things together without something like this in the middle. So I'm going to take this featherwing that has the big old school DIN 5 connectors off. I can plug in this MIDI connector that has the little 3.5 millimeter jacks there. Grab. This does have a little ribbon keyboard on there you can kind of use. But I'll just use a regular 3.5 millimeter stereo cable there, TRS. And so now MIDI out from that, MIDI in to that. And whoops, let's, so this one doesn't really have presets as far as I recall, but it does have the ability to change the basic parameters of it. So I don't know. Let's try program changes. Who knows? Nope, I don't think it's implemented. So I don't think this stores patches. Maybe some of the CCs are. Nope. Nope. But again, you can whatever the thing can do. So this thing can be used as a drum pad. So if the thing you're going out to is a drum synth on the other end, I have some old school drum synths that would work with. You could use those, or again, the arpeggiator. You can turn on some cool delay. And mess around with filters. That's not doing much. And then the type of envelope for, oh, now the filter's kicked in. All right, so that's a little tour of some of the things that you can do. I'm very excited about this, and I'll do some more so that this itself can handle more things like its, own arpeggiator, or being able to do some filtering, do some on-the-fly adjustment of MIDI channels. You can do a lot with just a little bit of interface on here to say incoming CCs go one way and come out another as a different value or a different range. There's a lot of possibilities there. And I think it's kind of a neat form factor, so I'll probably see if I can get a bigger OLED working. There was the OLED featherwing that fills that space that I have was the one that was broken, that was causing me some sadness this morning. So I just have a little Stemma QT one on there right now. But a little more size on that interface would be nice. Oh, good, and now that's going out Everything's flaking out on here. What's going on? And let's try resetting that. There we go. I might make like a little case for this or something like that so that it's portable. Maybe plop a battery under there, not this gigantic one, but pop a little battery on there so you can avoid needing multiple connections there and avoid ground loops and things like that. So that's our happy news with that host Featherwing. Some questions in the chat about, let me go back here and check my Discord. Oh, question about TRS Trinky. Can it send and receive MIDI directly? Yeah, Todd says it cannot, just because of the spec on MIDI is usually a little opto-isolator chip and current limiting resistors. And on the input, you need the opto-isolator. Yeah, so I don't know. You might be able to get away with it, but not within spec. So there you go. Yeah, so that's what it's doing. Here is the code for this. So I mentioned I've got the easy USB MIDI host. And then a lot of this I don't understand and haven't looked at enough to talk intelligently about enough, but just to say the key things for me are these functions like node off, node on. What do they do? Well, right now they're being called by incoming messages down in one of the two loops because there's concurrent loops happening with the two cores on here. So one of the two loops will read the messages and then send them to get processed by these different functions depending on the message type. So a node off message that comes in on the host gets sent out with this. So it's sent out over MIDI USB and it's sent out over MIDI UART, and then it prints to the serial monitor, and then I added this code here to do a printf to the little OLED display. So it's just a straightforward mirroring of the node on, node off right now. And you can see the multiple setups. So here's setup 1. That's running on core 1, as the RP2040 has the two cores. And there's loop 1, which is just this USB host task. And then core 0 is running all of the display code that I have, all of the MIDI setup for basically echoing those messages out or filtering them if we're going to. And then this is the main loop here. There was a question in the YouTube chat. Squinter said, what CircuitPython optimizations can be done to get it working? That's an excellent question. There is a, let me find it. There is a bug report that, oh, there, wait, is that it? I think it's Adafruit CircuitPython USB host MIDI issues, and I'm going to paste that in the chat if anyone's curious. So that's the issue that's kind of currently happening with the CircuitPython host there. Oh wait, is that the issue? I thought there was a more elaborate one. Huh. Yeah, well, that's at least a starting point for where that's going. But I know that Scott was looking at it. There were some updates to Tiny USB to start helping. And if anyone in the chat over on Discord has more information about that, let me know. I'll repost that here, or I'll go to that page. But that is what's going on there. Oh, was I not showing that? I don't know if I was showing that. That's the issue there. So I posted that over in the YouTube chat. You can check that. Back to the Arduino code here. Yeah, you can see it's got a really simple loop here for the core, which is just USB MIDI read all, and that's what then sends those messages out to all those other little functions, and then write flush all. So that's it. That's that example that I showed from the library, easy USB MIDI host PIO example. And that'll be in a Learn guide that I put together that'll make this kind of an easy plug-and-play solution for some MIDI hosting. Super exciting. All right, I will remind you, if you want to go buy some stuff in the store, you can get 10% off with this coupon code right here, Phaser. Head to your local Adafruit store. That's out of stock right now, but for stuff that's in stock, you can get it for 10% off. And if you are wondering about getting free stuff on top of your 10% off, these are the current deals that we have going. For orders of $99 or more, you get a free PCB coaster. $149 or more, you get the coaster and a KB2040. $199 or more, you get both of those, as well as free UPS ground shipping in the continental United States. And at $299 or more, you get the coaster, the the KB2040, the free ground shipping, and a free Circuit Playground Express. So those are some breakpoints for spending bunches of your hard-earned money at Adafruit, which we appreciate greatly because it's how we keep the lights on here at Adafruit. So use that coupon code today, Phaser. That'll be good until midnight tonight. Let's see, I think that's going to do it. So thanks everyone for stopping by. Tune in. I believe tomorrow we have a deep dive with Foamy Guy, Tim. I believe Scott is out, but Foamy Guy will be streaming, I believe, tomorrow, deep dive. And then we'll be back next week with another round of shows, including Product Pick, 3D Hangouts, Show and Tell, Ask an Engineer, Desk of Lady Ada. All those good things should be coming to you, so keep your eyeballs peeled on the Adafruit YouTube and blog and live broadcast announce channel over in Discord. Okay, hey, thanks everyone so much. I hope you have a good one, and I will see you soon. Bye-bye.
Thank you.